Okay, everybody, thank you for joining us this afternoon. We'll try to be on time because I know we're the ones stopping you from all the drinks and dinners coming up shortly here. Thank you again for coming. How many people know about SDN? Oh, nice. How many people know about SDN, software-defined networks? Oh, okay, good. So I think hopefully you'll like this. I'm your host, and we have a number of presenters that are going to show you not only that this technology is being pioneered in the standards, and we'll give you the concepts, but also we're going to see actual live product demonstrations of this stuff working in real life and shippable products. So hopefully you'll really enjoy this. My name is Pascal Monez. Like I said, I'm a principal program manager at Microsoft. I'm actually the chair of the SDN group for the Unified Communication Interoperability Forum. This is a sponsored session by the UCI Forum. And I'm also the vice chair of the Open Network Foundation Northbound Interface Group. So actually, that gives me, I'm very blessed to kind of see both worlds and see how this all applies. And hopefully we'll paint a great story for you guys to really appreciate. Does this work? Oops. Okay, there we go. So the agenda is, what is UCI Forum? And I'll talk about that. What is SDN? And standardization efforts in the SDN development, and then scenarios and demonstrations by our vendor participants. Let me make sure I got my timer set, because we each have 10 minutes. And no, I didn't, so I get an extra minute there, I guess. Yeah. Okay, great. So let's start. So the UCI Forum, I'll just give a little blurb about the UCI Forum. Basically, founded in 2010. Basically, the whole premise is to make sure we get great interoperability between for UC vendors from various subjects, which I'll show shortly. And the group exists to really get to a certification interoperability program. About 29 members today. We hope we'll get more members joining. We really want to see this rich ecosystem of UC systems working together in a standard way through interoperability. The structure today, we obviously have a board of directors. The one that's interesting there is you have some work groups, marketing, you have test certification and technical. And the technical one is what we're going to focus on right now, specifically around, as you could see, SDN. We have other work groups, video. We have this MAME, which is Media Aware Network Elements, which is in the IATF, about having these intermediate middle box be very aware of the RTP flows coming in. And SIP-v6 actually, just interesting enough, just got out of that technical task group and gone to the test and certification group. And so we actually have the first implementation of doing testing for DoD and interoperability for SIP-v6. It's actually a very great program. We're going to focus on SDN, and let me go through that in details. So basically what we found is in the Link and Skype group, and I don't know how many UC vendors a year, we found that the majority of our issues that we've been seeing when customers complain is that basically 68% of the issues are network related. So yet the end users complain, hey, you know, I had a bad experience in the call and it's Link or it's Skype. The answer is when we look and we do deep dive investigation, 68% have to do with network issues. And some of the issues are we, by default, encrypt for great security, both signaling and media. And a lot of enterprise UC systems do the same thing. And what happens is the networks really don't get visibility into this as to what's going on with all their deep packet inspection engines and so on. And what we find is for the enterprise, unlike the consumer version, in the enterprise, you must enable quality of service end-to-end. And I think if I don't have a slide, maybe I think Manfred has a slide on this on how complicated it is to provision quality of service. It's a huge complexity to turn on quality of service, not only in the network, which is a lot of work to get end-to-end, and normally you'll see they strip off tags and things don't work, and then keeping it, even you get all perfect, keeping it from drifting and what we call configuration drift, which means as time goes on, things change, people don't know what the settings are, and that causes you a lot of broken parts. And then also you have to configure Link itself for putting on the right tags, and by default that is not enabled, so you have to actually do that. And so at the end of the day, what we want to do is basically just have a great end user experience because we want the network to be high quality. So why SDN? Software-defined networks really does some really amazing things, as you're going to see from all our vendors here showing some great products. At the end of the day, we have a huge complexity happening, and this complexity is basically, just adding up more and more. It's not changing. It's getting worse and worse complexity. The cost to operate these things are getting more and more expensive. You can see many sessions from providers and enterprises that are complaining about the cost efficiencies, the OpEx. Basically, if you went to the Open Network Summit, Vinod talked about this. If you looked at the Pac-Man kind of idea of the round circle with a little square in it, most of it was OpEx issues. And then finally, we want to improve end user experience. The great thing about software-defined networks is you actually get visibility and control into what's going on. We're going to show you why. And you can get to automation and agility. And this is really what you're going to see from our vendors here. They're actually doing some automation agility, right, and showing visibility and control. Let me see. So in the SDN architecture, I just want to give a little overview. Basically, you have the network elements. They get programmed by the southbound interface, and this is dynamic and by flows, which is very powerful, and it's very real time. And the controller has a centralized intelligence, which is really cool. And the bottom line is with the centralized intelligence, it has a global view of what's going on. And so the control plane is centralized versus distributed in the old days of internetworking with every network element having that. And more importantly, the SDN applications is where we're talking about now. The northbound interface is we're now innovating on that. As a southbound interface, we have OpenFlow as the de facto standard by the ONF, and there's other southbound interfaces that are proprietary, but the northbound interface is what we're going to show you about, and we're going to talk about that specific logic and network service intelligence. So here's a standard model following this example of the architecture. Now we get more details, and what you see, the network elements get programmed by that southbound interface like OpenFlow. The controller has specific modules like topology module, inventory module, flow programming module, statistic modules. And these modules, what they do is they have low-level functions. So if something wants to know about topology, it calls into it through that northbound interface and says, give me the topology of these end stations or these devices. So that's what the SDN controller has, all the centralized knowledge, global views. However, it does not have the analytical logic to piece things together, okay? So think like a correlation engine or analytical kind of model engine. This is what the network service application is about, is actually has this intelligence. And you're going to see from Nectar, Aruba, HP, that they've actually built this network service intelligent layer. And this is what the SDN community has been calling an application, an SDN application. And today you're mainly seeing that as orchestration applications, network virtualization applications. However, this could be a traffic engineering application, a QoS application, a diagnostic application, a Wi-Fi application, very powerful paradigm. And what we're going to show you in UC SDN is even take this one step even better and higher. In the UC SDN model, we get the idea that we have an end user app, like UC, programming the analytical network service application for its QoS traffic engineering, telling about flows and what's going on. And then the SDN controller, and then the network app goes down and talks to the different modules of the SDN controller, like gets topology, and then looks at, for example, statistics, and then programs a flow. This is what the network service app does when it gets this information from the UC. And we're going to talk about what does it get from this UC application. Again, the UC application has long-lived flows, so when you do a voice or video call, it lasts for minutes to hours. So it's a perfect example of a great application for programming the network. Great level of abstractions, and what I mean by abstraction is exactly this. Here's the same level application talking to the network service app, talking to the SDN controller, talking to the network element, but from us, as a UC SDN interface, we just see this intelligent black box. We program this intelligent black box, and the sessions, Linda and James, just work flawlessly. That's really what the mission, the goal is, what we're trying to achieve here. And you're actually going to see shipping products doing some of this. So the UC SDN dialogue event, Basically, this is a construct of how it works for the UC-SDN interface. And what happens is, as signaling starts up, it gets propagated to the endpoint, media starts flowing between the two endpoints, and as media flows right away, the UC system sends down to this network service app and the controller. In this case, I'm showing it together. It programs exactly what's going on with the flow. It's a video flow, it's a voice flow, here's the IP points involved, where codecs is involved, and so on. And that's called what we call a dialogue event. So it's programming the start of a session. The session's ended, we can say end of a session, an update of session, going from voice and video and data, and so on. So finally, that programs down after then the network elements. The other thing, for example, when there's an error, for example, we can actually get the error show up in the media, and then right away we can send down there's a problem with the session, and this is what we call a quality update event, and now the network can fix itself. And this is really, truly a very powerful paradigm of automation. And you can see here it programs itself, and the problem clears away. So in the UCI forum, what we've done is we've started the standardization effort, and basically, let me just turn this timer off because it's going to go on me. And basically, we actually have a working group. It's a task group, and we have basically standardized use cases, and that's what we're on right now. I'll talk about in a second. And we actually have a leadership team. As you can see, I'm the chair of this, and we also have Chris as a co-chair, and Manfred and Tanu from Aruba, who's actually doing a lot of the subject matter experts and so on. And there's many other participants that are helping out too. This is just some example of the leadership team. But we have a liaison agreement to the Open Network Foundation, and the Open Network Foundation, who's doing the northbound interface, is taking our use cases, and they're actually defining the actual interface, this northbound interface for UC-SDN. And that group is divided into 3 subgroups: architecture, cloud, and then end user app. And I'm the vice chair of the end user app. So as you can see, I get this great visibility between the two worlds. And again, on the leadership team, we have HP, Sarwar is leading that, and we have Tina from Huawei, Dave from HP, and myself. So this is how we're kind of orchestrating together and to redefine this whole idea of end user app. One takeaway I want you to think about is end user applications programming the network. Like, that's a very powerful paradigm. And this is what we're talking about. And we're actually going to show you actual demonstrations from our partners doing this in real life, shipping products prior to standardization, which we're going to standardize. These are some of the scenarios being done. Automating QoS just got completed in our task group. We're now sent that over to the ONF, and they're building the interface for that. Dynamic traffic engineer bandwidth for every class of service is in progress. We're defining that. And call and mission control. We have Wi-Fi, security, diagnostics, firewall. You're going to see that in some of our vendors' presentation. Contact information. If you want to join the UCI forum, please contact Linda, or go to the website and join there. And there are some of the board members that are involved. And basically, let me see. So with that, I'm going to have our speakers come up, and they're each going to go through about 10 minutes each about their specific UC-SDN application and how the SUC itself programs their environment and do some very powerful things. So the first up, I'll have Manfred from HP, and I'll let him take it from here. Thank you. Here, Manfred. Down is up. Down is the next slide.
Okay. Thanks for the introduction, Pascal. I'm Manfred Arndt. I'm the Chief Technologist for UC&C from HP Networking, and I've been working on UC&C since 2003 and Microsoft Link Solutions since about 2008. I'm very involved with driving SDN architectures, and I feel we're at a very exciting point in the industry right now. I feel networking is broken. Applications have gotten much more powerful, much more agile. The cloud and the data center. Networking is still brittle. We program it on a box-by-box basis with cryptic CLI. That was fine when we were running basic email or very basic applications that are using best effort traffic. But when we want to start doing very dynamic and agile things, it's getting in the way. I'm also on the UCIF board of directors, and I'm also involved very much with IEEE and Wi-Fi Alliance initiatives. Another initiative I'm driving is mobile multimedia to try to help mobile clients, the sticky client problem, trying to address that. So as Pascal was highlighting, there are some challenges around UC&C solutions, because one thing is it's now become an application. It's not a PBX anymore. It's not a hard. It's an application that lives in a data center. And you've got two different domain experts kind of provisioning things. The UC application will be provisioning things like what DSCP code points would my application use, or what are the port numbers that the application would be in programming the application. And then he has to talk to the network guy and say, give me, provision these classes of service and recognize these applications in the network. And that gets very brittle and complex. As Pascal was highlighting, 60 to 80% of the audio quality issues are because there's some misconfiguration in the network. And QoS is like a chain. It's only as good as the weakest link. And all it takes is one problem somewhere along the path to cause an issue. And the problem with that is, under normal circumstances, everything seems okay. So it's not like testing connectivity. Connectivity is very easy to test. It either works or it doesn't. QoS is very hard to prove that it works, because just because it works 1 minute doesn't mean you've got it configured right. And this is where we believe automating what is a manual, very tedious process that no human being should be doing, we believe that SDN will really transform that and make that a dynamic solution. So what we introduced is something called the Network Optimizer SDN application. And as you can see, the UC&C application will use a northbound API, so RESTful API. When a call is initiated, to send it to our application. Our application then will use that. And the UC application knows who's talking to who. The UC application knows what they're trying to do. So it knows they're trying to do voice, video, desktop sharing. It even knows how much bandwidth they're trying to use. It knows things like IP address. It knows things like port numbers. It just doesn't know physical topology. The network knows physical topology. It knows IP addresses and port numbers. It just doesn't know what the application is. By bringing those two together, we can now dynamically provision QoS on a per-call basis at the beginning of the call, and then tear it down at the end of the call. So really dramatically simplify that. So let me highlight, Pascal showed the slide, so I'm not going to talk too much about it. But the part that we're trying to do is really provide a level of abstraction where the application programmer doesn't have to know physical topology. It has to know what type of class of service do I want. Do I want am I running a real-time video service? Am I running a voice kind of solution? And the network administrator still should have a way to change the policy. We're going to create defaults that were going to be correct for most cases, but the administrator still needs a way to set policy, but it should be a very high-level policy. It shouldn't be a policy that's on a per-switch basis. It shouldn't be very detailed policies that's switch-specific or technology-specific, because, for example, the amount of QoS queues you have in Wi-Fi differs what you get on wired switching, differs than what you might have on an MPLS router. So we need to abstract that, so allow the network layer, the network services layer, to dynamic provision that based on a high-level policy. So let me give you a little demo here.
Take, for example, two employees attempting to collaborate via link using application sharing. On the top left, we have the user James, and on the bottom left, we have the user Linda. James initiates a call to Linda and then starts sharing an application. As you can see, Linda's user experience is significantly delayed and not synchronized with what James is sharing. This is not a problem with link, but rather an issue with how the link traffic is handled across the network. This poor user experience is all too common with today's UC&C solutions. In fact, users are not only frustrated by this, they have come to expect this type of experience as the norm. The reality is that poor application performance is a drain on productivity and limits the power of unified communications and collaboration solutions. On the right-hand side of the screen, we have the HP UC&C application in a disabled state. When we enable the application, the user experience is instantly transformed. Now both users are seeing virtually the same information at the same time. The UCNC SDN application has taken call intelligence from the Link server and used it to implement OpenFlow rules via the HP Virtual Application Network's SDN controller.
Pretty cool, huh? So what I'd like to show is drill down a little bit under the hood, kind of just to give you a high-level view of what we're doing. And a common question I hear from people, well, this is pretty cool, but it's going to take a while for SDN to get deployed. So how can I deploy something like this today? And the reality is one great thing about OpenFlow is you can run it in a hybrid model. Okay? And what we're trying to drive as HP, we believe, is rather than just reinventing the wheel and doing the same thing you've done before a new way, that's not real compelling. What we want to do is drive new use cases and show how we can use SDN and OpenFlow to solve things like QoS, security, network access control, diagnostics, because those are things that are really hard to do today. Show how we can incrementally implement SDN and OpenFlow in a hybrid model and then leverage that in a piecemeal fashion to take advantage of the network. Once customers are comfortable with that, then embracing a full SDN model makes sense. But trying to have them say you can't take advantage of this until you do a complete replacement, that doesn't fly outside the data center. Okay? When's the last time you've seen a greenfield deployment in a campus and branch? So we believe that this hybrid model is really transformative to try to make that work. And so when user James calls Linda, the UCNC application knows all this information, sends it to our app, and then what we do is use an OpenFlow policy to provision only some of the switches. And ideally, it should be the access layer. Okay? And if we do that, and it doesn't have to be everywhere, but wherever we do that, that's where we can start taking advantage of that. And these switches are running in a hybrid mode, so things like spanning tree, routing protocols are still done the old way, but we're just using OpenFlow to do a modify of the packet. So now the DHCP header in the IP packet has the right value. And then the rest of the network, including your WAN routers or your MPLS network, can now honor those settings. Because the hardest thing with QoS was really just recognizing the application. Once you knew what that application was, then honoring was easy. But we've now solved the hardest part in QoS doing this. The other part that I want to highlight is HP's been shipping OpenFlow capable products for over 5 years. We have now over 50 models of switches that are OpenFlow enabled and capable, and we got over 25 million ports deployed in customer networks. So what this means is this isn't just a science fair that says, okay, come tomorrow you can start buying new products, and maybe 5 years you can start taking advantage of this. This is something that customers can start taking advantage today. If they already have some HP OpenFlow enabled products out there, they just need to now enable that feature and deploy this application, and they can start getting some very innovative and compelling technology out there. The other thing I want to highlight is HP really believes that SDN is going to be so powerful that we're really trying to highlight not just what we're doing with UCNC, we're trying to highlight a lot of other compelling use cases as well and build a complete end-to-end ecosystem, including switches. We've got routers that we've announced that we're going to be OpenFlow capable. We've got wireless access points. We've got our own controller and a whole app store that we're building because we want to encourage an adoption of other solutions that it can integrate with our portfolio here. Thank you. Did you switch over?
That was too.
Good afternoon. I'm Tanya Monasterio, and I'm joining today from Aruba Networks. Unfortunately, my colleague Senu, that you saw earlier on the name listed there, is not here today. I am taking her place. So, a few things that Aruba approached, when thinking about deploying a UC application in a wireless environment and some of the challenges involved today. The more customers we talk to, the more we're seeing customers are going to this environment. Cubes are going away. How many of you, for example, have more than one device, right? And how many of those devices have network ports these days? So the challenge that we have in reality today is between consumerization of IT, bringing your own device, changing the way we work in our actual workplaces of work and where we work meant that we have unique challenges when it comes to delivering these UC applications on all types of devices over a wireless infrastructure. So to this end, Aruba recognized the fact that most users have multiple devices, and these clients are not always optimized for the best UC experience or the best wireless experience. So Aruba approaches to go beyond the clients that get sticky to APs, but also having a good experience as you use UC in your environment. If you want to roam between, people are now used to using an iPad, and you start a video call and you want to grab a coffee, and you don't expect to drop a call. You just expect, as an end user, you expect a good experience, you expect it to just work all the time. So to that end, we took the SDN API from Microsoft and basically approached it with these specific challenges. First of all, on the client side, as I just mentioned, high client diversity. Everyone's bringing multiple different clients that are not corporately provisioned typically in your environment, not optimized for roaming, and a lot of these clients don't actually support upstream tagging. So we don't really know, what packets we're receiving from these clients. There are also, obviously, Wi-Fi is limited, right? It is what it is. We're working with a fairly limited resource, and there is we still depend, for traditional WMM, depend on correct prioritization and tagging. And then, of course, there's also, when from the wired network, we won't always get the correct tagging, and some of the legacy environments may not have been provisioned correctly, and some of the UC servers don't necessarily apply its own tag. So these are some of the base, challenges around the Wi-Fi environment, and bringing a UC application specifically to a very mixed, diverse wireless environment. I'm not going to spend on this. You've seen now Pascal and Manfred actually talking about this, but essentially using the exact same model of northbound APIs, informing the network infrastructure, the SDN controller, to have the best optimal experience for the end user on the different devices in the wireless environment. So when we look at Aruba specifically, what Aruba Networks did here is looking at, we're looking at the application layer. We have our controllers running specifically being SDN API aware, and then talking down to the infrastructure layer so that the infrastructure can change how it behaves by being informed by the UC application, which is really the key here. So to that end, we can prioritize, like we said before, you prioritize how you want to prioritize your voice traffic on these UC devices, your video traffic, your desktop sharing. Maybe you have different settings for each of those types of traffic, and in your environment, how you want to prioritize those. On top of just prioritizing, though, the one key thing around troubleshooting and end users and multiple devices is how on earth do you know where to start looking when there's an issue? Ultimately, people are going to have challenges, and how do you get that visibility? So again, that was a key piece here, is pushing out those post-call statistics, giving great visibility around diagnostics to actually be able to go back and say, if someone calls up and says, I had a bad call yesterday, where do I start to look? And actually having that information available, what device, where was the person, etc. So if we look at UC aware of Wi-Fi in action here, first of all, so we talked already about how the SDN manager will send in-call and post-call information. So when the call is initiated, the network gets informed right away that it's a voice call, it's a video call. We can then tag the packets appropriately and prioritize and route the packets, all these different streams appropriately. And again, because in this case, using Link, it's totally encrypted and it's not exactly clear and extremely visible to the network exactly what type of packets and what type of traffic we are routing. And when we escalate, for example, on a call from a desktop sharing session, adding video, adding multiple people, and adding different elements and more media into the call, and making sure that each of these packets are then correctly tagged, correctly prioritized, and then the last piece here is actually creating a UC-aware infrastructure so that when there's a wireless voice call going through my access point doesn't go offline and start scanning other access points to what wireless environments typically do. So making sure that while I have a voice call, which is real-time sensitive and media sensitive, that quality of service is guaranteed the duration of that call, and the access point doesn't do natural Wi-Fi access point things that will make a bad experience and result in a bad experience for the end user. So having done all that, so we can now improve the experiences going on, but bad issues are still going to happen with end users and the UC traffic. So the key piece here is to understand who called whom and overlay all the information that we get from currently the UC application, in this case Link, from the quality of experience monitoring server. We can then get there the quality, the call quality information, the R value, the packet loss, the jitter, etc., and combine that and overlay that with our client health information. So this is a piece that a lot of our customers are really excited about today, is the ability to see the usage trends. And I apologize, this is an eye chart, but this is essentially the Aruba Networks dashboard from OS 6.4 onwards. And up here I can see what type of traffic. So again, this is my UC dashboard. I can see what type of traffic came through. And then I can see, what type of device is or OS is most commonly used. So in this case, it'll actually be a lot of different blocks, and you'll see Android, you see iPhone, you see iPad, and up here you'll typically see a breakdown of different types of traffic that's coming through. And so these are the usage trends. So you can see what's out there, who's using, and what are they doing with it most commonly. And then on the other side of the screen, on the right-hand side, you can see here the troubleshooting elements. So there are a number of pieces. I can see the client health detail, and then also how did my client health overlay with my actual call experience. So if I zoom into that corner there, this matches my call quality versus my client health. So typically, it's straightforward here. If it's down here, it means I've got poor client health, and if I have a bad call, I suspect it's a Wi-Fi problem. I might want to look at the access point. I might want to see if there's roaming, which elements of the Wi-Fi actually degraded here. And if it's actually fantastic client health, but something else is wrong, then maybe we should look at some other elements here. So it's typically helping us narrow down on where to start troubleshooting and to actually resolve the issues that we have. So if we look at this example, again here I can see, potentially if I get consistently bad quality on users that are all using Windows 8, then we know the operating system is capable of actually correctly tagging the traffic that comes out. So in this case, I can actually say, well, perhaps I can apply my group policy. I need to look into that so that my Windows 8 clients could potentially be misconfigured, and that problem could be solved for a big batch of users. So that's kind of one example of how to go about it. There's also furthermore call statistics. So if the previous dashboard I was on was UCC, and if I go into clients, sorry, I'm not very steady hand. In this case, I've got Jenny, and she's calling the help desk and saying, I had a bad call. So now I can go into clients, and I'm looking just at Jenny's calls, and I'm looking at all the different calls that she had here. I can see what it was. They were linked calls. And I can drill down and see, was there any specific delay, or what elements occurred during those calls that actually impacted. And I can also see the user-specific trends as well as the individual call records. If I can then go into a specific call record even further and see what was the original tagging. In this case, I can see there was no client-side tagging, and then based on the API information we received from the application, re-tag those packets and then reprioritize them on. So again, that's the type of where I can see where the retagging took place, as well as any other modifications that took place. On this same screen, further down that I can't, it's not showing up right now, I can also see whether or not the client was actually roaming during this call. So if this person was standing potentially, at 2 o'clock next to the kitchen where there's a bunch of microwaves, and suddenly it's got bad call quality because the meeting room is attached, shares a common wall, then we can kind of spot, that time of day, this type of location, typically it's been Wi-Fi interference, potentially. So I can then look at those types of detail and drill down into that. And this one here, again, I can go more deeply into the call and see exactly who did Jenny call, who did she talk to, did she have a video call, did she roam between access points, what was the experience that she had, or was it a device-specific challenge that existed, and I can go down into the individual call details. So that challenge where someone said, by the way, last Thursday in this meeting room, I just couldn't do a media call on my device over wireless, actually starting to give the administrators some of those tools to actually start drilling down and understanding what is involved. From Aruba, we're actually trying to now take this to the next stage where now we've got the call quality metrics from the QoE server, the client health information from the wireless network, and now combining that with a floor plan environment. So you can see these are the devices out there on my floor plan, and the green ones are the ones that are happy, and I can spot the red ones that don't have good client health or having bad call quality, and then drilling down into those things. So Aruba believes that using SDN and the UC API, we'll be able to continue to give customers best visibility in a really challenging, diverse environment, in a wireless-enabled environment, running complex applications that are encrypted with real-time media sensitivity. So that's my piece. Thanks.
Testing. Okay, thank you. Thank you. Good afternoon. My name is Joseph Fucillo. I'm the Chief Technology Officer for Nectar. We are a UC management and diagnostics platform, multi-vendor. So just want to, because going to get a good sense of the audience. So in the room here, end users who runs via Cisco and Nortel, UC people, PBX guys, people who run phone systems here? Any? Okay, good. Vendors, anyone from the vendor community? Couple, okay. So building on this, on the presentation here, we're going to basically follow the same theme, but we're going to extend this into kind of some more areas of the situation. So I think we've kind of, if you look at the marketplace today and what people do, a lot of it is post-call diagnostic. Some manufacturers will provide in their call detail record, they'll provide a quality score associated with it, either loosely coupled or sometimes directly coupled to it. Some tools provide some visibility information. You can by vendor, but there's very little knowledge in network. And then as we move and progress into encrypted, where we look at, as we mentioned, SRTP, TLS for signaling, Link is, as we talked earlier, is natively encrypted. It creates a problem where traditional probes, that a lot of people deploy probes. I don't know, any guys, anyone have probes in their network analyzing traffic as they fly by in the wire? Probes approach, they're really good, but the probe only sees what passes by it. And if it's encrypted, it's not even sure what it's looking at any longer. So probes are going to continue to have a challenge without some other information. And it's very manual, it's very expensive, and it's very difficult to provide real-time diagnostics. And what you get is, you get a lot of finger pointing, because the challenge in UC is you have the voice team, you have the network team, you have the desktop application team, you have different groups, and the user experience is horizontal across them. And whenever something doesn't go wrong, it's one of these. Part of it's because you can't see what you don't know, and you're not sure what the problem domain is. So what we focus in on doing is really looking at the entire ecosystem and breaking the ecosystem down by components and providing really good visibility into each part. So you've got the UC infrastructure elements itself, okay? And then you have the endpoint. So from a Nectar standpoint, we talk UC, we're talking all the major vendors, Cisco, Avaya, Legacy, Nortel, Link, of course, and some other environments. And if it's SIP or uses some of the protocols. And then you look at the ecosystem, well, it's not just the PBX components. Well, there's gateways, the session border controllers, there's TDM gateways that are involved. So there's more devices involved that transcode media, change media, that are involved in moving packets. And then you start bringing in the network elements. And this is why it's complex, right? And then so any one of these domains can cause a problem to a user experience. And it's fairly easy for people to find the problem where it's hard down. When something breaks and all the traffic's broken, even a bad engineer eventually figure it out. but it's the intermittent ones, right? It comes and go, random times of the day, intermittent problems. It's very hard to spot these trends, and it's getting worse. And then we start looking at UC where, most networks we see today, and you guys probably have this, you have the low latency queue. You define how much traffic you expect to see. Someone hard codes how much bandwidth you think you're going to need based on voice streams, and you program that across the network manually. And then you have video. You have the ability to move around today collaboratively. Patterns change. So what is it? Is it a voice call? Is it a chat session? Is it a video stream? Two users are on a point-to-point call. They drag some other people in. Now you got a conference going. And what also makes this very challenging to deliver is that most traffic patterns today, it's very straightforward. You get a centralized data center and you have users. So people keep consolidating the apps in the data center. So network teams kind of understand edge to the flow, but UC is edge to edge, client to client. So there's not a lot of traffic flows necessarily in other applications going from client to client across the network, across the spokes on that MPLS cloud, don't many of you have, but in this case you have it. So what we do is we take real-time traffic information and we combine that with the ability to understand sessions, signaling, who's talking, and then we peer as a diagnostic controller, as a UC, as a controller, as an SDN controller, we peer at the network. So we understand routing hops, route topology. We speak various routing protocols in a multi-vendor environment. So we understand BGP, OSPF, and think of it as like a Google map or a Bing map for the whole world. We understand exactly how you're going to get from point A to point B. So when a call starts and the SDN controller tells us session starting, as we saw earlier, we know exactly how the endpoints are talking, what path they're going through. So in our application, you could pick on any router in that network and we'll tell you exactly what flows are going through, what calls are traversing it, voice or video. And if there's any events, a change in topology, a route issue, a QoS issue, whatever the problem might be, we know exactly the device and what calls were affected. So proactively, we call it the where and the why. A lot of tools report on the, they'll report on the, there's a lot of tools. Microsoft provides us a wonderful diagnostic number, a MOS score on the quality. And there's a lot of reporting on that number. But that's great, but then the next question is, why did it happen and where did it happen? And how do I prevent, and then the future, where we all want to get to is, now that I know there's something not good happening, how do I reprogram the network to avoid those future scenarios? And that's where we're kind of getting to, but there's a lot of involvement, and you can see there are some products that they can do it. So what we're doing is we're taking all this information, we wrap it up into what we call a quality of session record, which includes all of the CDR information, all of the quality information, the router paths the call went through, the diagnostic information, and you could search for it by phone call, or by router or by device. So for the first time, you could sit there in all those silos and see a horizontal view across them. And essentially how do we do it is the software nodes are talking to the routed network. We're also talking to the UC components. We're gathering information, and we're tying it, and we're correlating and just pulling it all together. And what next we're going to do is show a video, and this video basically is going to show a real live troubleshooting scenario where we're going to pull up a call and look through it.
As the first qualified depth partner for Microsoft Link's SDN API program, this video will take you through a brief tour of our unified communications diagnostics platform. We'll explain how only Nectar can provide you with the insight and monitoring you need to proactively manage your entire Link ecosystem. Imagine I have a Link user complaining because he's experienced a number of bad calls over the past week. The first thing I'll do is enter his SIP URI or ID number and look at the previous week's history. With the DVR capability of the UC Diagnostics platform, I'm able to view all the calls the user made over the past week. I get a lot of information from this tab. I can view not only network loss, but jitter discard if there was any congestion on the call or a path change. I'm going to look at the worst call here. The best MOS score this call could have received was a 4.25, but the call measured 1.45. So I'm going to highlight this session and click on the Investigate button. What will come back is the quality of session record. This gives me several key pieces of information. Up top is the session summary, the time the call was placed, the duration, and the to and from IDs. It will also highlight in red if there was a problem with this call. As I continue to drill down, I can see the topology map of the call through the network. The red indicates there were problems in that area. We can also expand the content statistics, and these match up very nicely. When using the Microsoft Link SDN API, you're not required to have probes in the network. However, for the purposes of bracketing and to be able to quickly isolate issues, we recommend putting our Service Visibility Analyzer near a voice gateway as traffic enters and leaves your data center. In this case, I have one here as it leaves my client routed network and heads out to the remote site prior to going into the carrier cloud. I can see that as the call began, it reported a MOS score of 4.13. Note where the A here matches up to the monitoring point above. I know this is a link call because there's an L at the endpoint. As well, I'm getting information from the endpoint, and that's highlighted in here B. The information is coming direct from the Link API, and I can see this call experienced problems and dropped to a 1.5 MOS score with about 4,100 packets dropped. As the call returned to the originating source, I can see that it corrected itself, and the endpoint, while still degraded, wasn't nearly as bad as the receiving endpoint. Here, I see a MOS score of 3.14 and a few dropped packets, but the call did improve somewhat. Based on our knowledge of the path and our integration with the Link SDN API, we can see here that the problem exists between DAO CE1 and DAO Core 1. We can see by the red triangle that this is where the priority queue usage alert took place. From here, we can dive into NetFlow, the topology view, or the QoS analysis. If we click on the QoS tab, what will come back is a query over the time frame we want to review. We'll look at the last hour. If we hover over the legend, we can see which apps are set in the priority queue versus non-priority. On this interface, critical data, video conferencing, Link, and voice are set in the priority queue. Link is the light green line on this graph. By hovering over any point, we can begin to see how many packets Link was dropping at a peak on that particular interface. We can see here that at a peak, we were dropping over 368,000 packets overall on Link during that particular time. That would give us some indication there was a QoS misconfiguration or usage of the application has grown, and we have not made adjustments to the router to accommodate that. If we zoom in on the bandwidth utilization and look at the same point where all the packets were being dropped, we'll see that even though Link was engineered for 5%, it was trying to accommodate just under 30%.
So I'm going to stop there and give a chance. Does anyone have any questions on this? Because I cut it short about a minute just to accommodate if anyone has any questions or anything.
Is this all post-facto? Meaning you're looking at a snapshot of the past?
So it's captured real time. So and the SDN API gives you when the call starts, so that we could calculate and correlate all the info. You're typically looking at a post event. I mean, you can see real time if you're staring at the screen, and most operation centers aren't really going to be staring there looking at the screen, but it is captured real time. Problems are identified, and then they're flagged up for review with the diagnostics. Yeah. So next, I'd like to bring up Verizon, who can talk about how they're using all this in the real world to provide service delivery.
Thanks, Joe.
I'll get you.
You got it? Okay. I don't have a ton of slides, but you can see there's a lot of complexity to networks, to monitoring them, to running QoS, to doing things with Wi-Fi, to running across all of these different aspects that we have. Inside Verizon, as a managed service provider and a network provider, we have a solution that we've put together for a long period of time, and it has to do with all of our diagnostics and how we look at the network, how we manage it appropriately, how we help run quality within our own network, as well as handling that from a customer perspective. And what that is what's called our impact platform. And what that does is handles the different areas that you can see up there around our fault detection and restoration and management systems that run through those, and they're quite extensive in different areas. We do a lot of things where we've looked at the best practices over the years, right? What kind of things have we seen? What works best for the different networks, for the different connections and capabilities across the board for each of those, as well as the proactive detecting of outages and performing fault isolation and things, which obviously is very important in these areas. And so how does this, incorporate or handle the things that the UC API and SDN capabilities within Microsoft help us out? Right? If you look at how this works with us, what we've done with our impact tool is taken SCOM and integrated that directly into that reporting tool set. So we're able to put the gateways and the agents onto the Link servers, monitor those across there with all the other network pieces inside of a Microsoft solution. And we feed that information into our Ionics and our smarts and our LAN and WAN analysis pieces, and then what we're doing is testing out and working on the Nectar portions in order to help us, as you saw a few minutes ago, of what kind of things are really going on when you're able to look at the Link voice, which doesn't come across right in a standard normal way, right? We're not able to look at it from that perspective. It's not tagged the same way as others are. And so we're testing out, we're working on the Nectar pieces in order to give us correct alarm and event collection information so that we can see the information that's coming through as quickly as possible. That information comes to us. We're able to then be much more proactive, and these are where these solutions are leading to make this easier for us as a managed service provider, but also for customers. Where the future of this is, as we get these solutions and the SDN pieces and UC APIs that plug in, it allows us to then take the information that you saw in the videos that come through and say, hey, we saw an event that came through a couple of minutes ago, let's say, and this person had a bad call experience, and it was because of some dropped packets in this router, and we had too much things kind of traveling through, right? What do we need to do about that? Then the help desk is able to start troubleshooting that, right? Because we, as Verizon, we get to see end-to-end the entire solution, right? Because as we manage those, we're doing it all the way across it. We're able to see all of the different pieces, but we also have control over those. So we can proactively go in, take a look at what was happening on that router, see if we can solve that problem, as well as at the same time getting a hold of a customer and saying, we saw that you had a problem on a call earlier today, and we want to let you know that we're working on it, or we've already fixed it, we've identified the issue, here's the issue that it was, and you shouldn't have experienced, or you shouldn't experience that issue again, to make that management capability so much better and a better user experience on the other end to see where those things are leading to, instead of having a customer call help desk later on 4 days later that says, hey, I was on a call on Wednesday and I've been busy since then, and I wanted you guys to go back and take a look at and see why at 1 o'clock in the afternoon I had a bad call, right, in where they're going. What a huge difference that is from a managed service provider to be able to provide that proactively up front. And where those go is they feed them in to the analysis and control and the presentation and how we put all those together to handle the traffic across there. And I think, there we go. As far as the slides and things that we do. But the message I really want to get across as we look at those things is that from an end user perspective and those managing networks and doing things, this really can help. There are things that are continuing to build and to get better and doing it rapidly to help those solutions and those problems that come up in a very complex world that allows us to simplify that and also be more proactive in that. And those are the ways that Verizon, as a service provider, are working those things in to make that experience better and to be able to provide the service from an end-to-end. And it is really end-to-end because we provide all of those pieces, right, from an IP trunking to the network connections itself, to the connections into the Wi-Fi, to the 4G LTE network, into your cloud or somebody else's cloud, and we're able to provide the secure connections in those. And so we get to look at it from a very unique view perspective. There we go. That wasn't me.
I want to thank everybody for coming, and I really appreciate that. I want to thank all our speakers, and thanks. We went over, but hopefully this was found really interesting. Again, you can go to the UCI forum, ucif.org, I believe, and you can actually, if any vendors or want to participate, you can join there. Love to get your views on that. We think this is actually a paradigm shift. Actual end user applications programming the networks is being tried for a long time, but I think with software defined networks, we really have this shot of making this happen. as you saw from demonstrations from vendors, these vendors are actually shipping products, and HPI, I think, is about to ship a product on this, and today it is, unfortunately, proprietary with the Link SDN API, but on the UCI forum, the ONF, we're going to standardize this. And my apologies to the other UCI forum members that we promote a little bit more Link, but they're also moving in this area, hopefully. And we're going to have an industry-wide standard of, UC systems talking to these networks and programming them to do the right things, reduce the TCO, automate all of this, and make this a really great user experience. And that's really what the goal of this whole initiative is. So thank you again. I'm sorry it went over, and hopefully you'll have a great dinner tonight. Thank you.